Hello, my name is Nick Perello, and I am going to talk about our work on marrying fairness and explainability in machine learning. This is a joint work with my advisor, Przemyslaw Grabowicz, and my peer, Aarshee Mishra at UMass Amherst. With the rise of automated decision-making systems, one of the most rapidly growing research areas in machine learning is how to measure and prevent discrimination. That is, how can we ensure that machine learning systems do not treat someone unfavorably because of their membership to a group characterized by protected features such as race or gender? Surprisingly independent from this, another increasingly popular machine learning research area is how can we explain these often black box systems to appropriate trust and improvements for them. For instance, given some sample in a machine learning model, how impactful was each of that sample's features to their predicted outcome? With the gap between fairness and explainability literature, it is often left unexplained how fair machine learning solutions work with respect to legal instruments, thus creating a barrier to the widespread adoption of such solutions. For instance, this connection is still a work in progress in one of the first and best books on fairness in machine learning by Salom Barocas et al. That many of you may have already heard of. Therefore, our work bridges this gap by joining fairness and explainability solutions together with legal text. Before we present our solutions, we must first understand the current challenges of fair machine learning using ideas from explainability and fairness text. Perhaps one of the most basic solutions is the idea of dropping the protected feature when creating a machine learning system. This would be analogous to someone saying they are colorblind when it comes to racism. This idea, however, remains discriminatory as the system can just find a proxy feature for the drop protected feature. For instance, as many of you know, redlining was a major problem in the United States during the 20th century. Using feature impact measures, we can present redlining using explainability literature. First, we can start with a model that directly discriminates and is impacted by race. Then, we can modify this model by dropping the impact of race, thus resulting in an increased impact of zip code as it is being used as a proxy for race. In other words, we are now redlining. On the other hand, many of the solutions popular in the past decade have been based on enforcing some notion of statistical fairness. For example, the notion of statistical parity, where members of each protected group have the same chance of getting a positive outcome. While this may achieve a balanced outcome, these solutions might drop the impact of features related to the protected feature that is necessary and legally allowed for decision making. For example, in the well-known Berkeley study of graduate applicants, it was found that men were accepted more often than women, which without context seems quite unfair. However, this can be partially explained by the fact that women often applied to more competitive departments than men at Berkeley during this time. If we built a system that tried to enforce statistical parity here, it may drop the impact of department choice to equalize the chances for men and women getting accepted. Therefore, we propose a solution where we drop the impact of the protected feature on decisions while ensuring the impact of the remaining features remains the same as the original model. This can be achieved by tying our work with explainability and causal influence literature to measure impact and then create relevant loss functions. With the ties to explainability literature, we can define discrimination in such a way that our methods have direct ties with legal instruments. Now, in the context of the example shown before, our solution in the redlining case removes the impact of race from the original model while leaving the impact of zip code at none. Meanwhile, in the Berkeley example, our solution will leave the impact of department choice the same as the original model. To achieve this, we take a number of steps. First, we define discrimination based on legal instruments and two influence measures grounded in causality and explainability research. Then, we create loss functions and methods that inhibit this discrimination. Lastly, we show that our method compares positively against several other fair learning methods on both synthetic and well-known real-world datasets. To learn more details of these steps, we encourage you to view our longer talk and paper. Thanks for watching.